Sometimes polynomials can contain binomial factors within each term. These can also be common. Let's take a look at this example. I know your reflex might be to distribute the 3x and the negative 2, but let's not do that. Let's take each term over on the right-hand side and break it apart into its factors, leaving the x plus 4 as its own factor. When we do this, we can see that the x plus 4 in fact is a common factor for both terms. So what we can do is pull the x plus 4 out in front, leave a fairly large bracket for our leftovers. We now take x plus 4 as the common factor and divide that within each term. The x plus 4's will cancel in both expressions and leave us with 3x minus 2 in the brackets. Tidying it up, we will have x plus 4 times 3x minus 2 as our factored expression. Sometimes, when polynomials appear more complicated, it's easier to substitute in a simpler term to see what's going on. So for this example, we'll notice that we have a b minus 7 in brackets. Well, that might look intimidating, so what we can do is let's make a substitution. Let's let the letter u equal b minus 7. So we can now replace the b minus 7 with the letter u and then rewrite our expression. This will give us 6a squared u plus 12au. Now let's take these two terms over on the right-hand side and break them apart into their factors. Doing this, we will notice that each of them has a 2 in common, a 3 in common, the letter a, and our newly substituted letter u, resulting in our common factor of 6au. So let's take this common factor and factor it out of the two terms. So again, we set up our bracket. We take the 6au and divide it into each of the terms. This will leave us an a for the first term and a 2 for the second term. Well, that wasn't so hard. The last thing we need to do is to take our letter u, substitute it back in for its original expression, b minus 7. Once we've done that, we're left with 6a times b minus 7 times a plus 2 as our factored expression.